Number 24. So, let's see. A mean of 150, standard deviation of 10. She earned a 175 on the math test. So how many standard deviations is she above the mean? Well, let's just do it. So there it is. So she is 2.5 standard deviations above the average. That's pretty good. So basically, if we look at the science test, 130 with a standard deviation of 15, so she's 2.5 15s above 130. So what is that? So there it is. 2.5 times the standard deviation gives us 37.5. Add that to the average, so she got a 167.5. I'm hoping that's one of our answers, and it is letter E. Okay, so on this one, two groups of computers, we're testing the speeds, we get this interval. So looking at the answers, the difference will be greater than 1.3 95% of the time. We cannot say that. Remember, we're just estimating. This is just one example. Let's see. Letter B, I'm going to skip letter C. Since the interval does not contain 0, there is no significant difference. Actually, it's the opposite. If the interval does not contain 0, there is a significant difference. Tricky. So letter D, 95% of the differences between the speeds will be between these two numbers. No, 95% of the differences will capture the true mean. We don't know what that is. That's definition of confidence level, which is the wrong definition. I thought it might be E, but you know, we use a two-sample t-test, which would be good in this case, and then we use a 95% confidence interval just to kind of back up what we say in our t-test. So we use both of those. So anyway, you end up with letter B. Sample size is too small. Now in this case, like you've taken AP exams, a lot of times, a lot of the answers are really close to being right. You just have to pick the most right one. So try to narrow it down to, like I did, I narrowed it down to B and E and ended up with B, which was the correct answer. There you go. So on this one, standard deviation, so 42%, right? And our sample size is 250. So 0.42 times 0.58 divided by the sample size, and you take the square root. That's going to be your standard deviation. Let me figure out what that is. Well, in this case, the answer, well, the standard deviation is 0.0312. The only one that has that right there as a standard deviation is letter D, and that is correct. So think about it this way. Let's just say your confidence interval, you get a proportion of, say, 50%. So 0.5 times 0.5 divided by 50, because that was your sample size, take the square root. Then you do it again, and you have a larger sample size. So 0.5, they said it was the same proportion, divided by 450. Well, when you divide by a larger number, your result is actually smaller. So it's a smaller standard deviation, which is going to give us a narrower confidence interval. So, I should probably redraw these, but I like them, so I'm going to keep them. There you go. Oh, wait, what's the answer? Width is going to be smaller, 3 times smaller. Oh, and the reason that it's 3 times smaller is that from 50 to 450, right, that's 9 times as big. 9 times as big, but we're taking the square root. So the square root of 9 is 3. So it's going to be 3 times smaller. Let's see, which one was that? 1/3. B is the answer, 27. Number 28. So we've talked about this a couple of times. This is the same person before and after. So before the drink, after the drink. Tapping, more tapping, we don't know. But it's the same person. So that's going to be a matched pairs situation. The very first time, I think, in the book they talk about is there was a leaf, right? And they put the solution on one side of the leaf like that, and then they did something to it and compared the two sides of the same leaf. Same leaf, okay? That's a matched pair situation. Okay, sometimes they use identical twins if they have two different people to test something. So anyway, letter E, matched pairs.